let's begin. This is Luca, L-U-C-A, the last universal common ancestor. Imagine a time long, long ago, billions of years in fact. Imagine a world where life as we know it is just beginning to take shape. Luca was not just any organism. It was a tiny yet incredibly sophisticated single-celled creature discovered just recently by microbiologist Carl Woese. To put it simply, Luca is our well, let's just say it's the grandparent of all life on Earth. And not just humans, but animals, plants, bacteria, fungi, every living thing you can think of came from this cell. From this ancient cellular origin, a profound and enduring connection has emerged, one that links the evolution of life with the evolution of human ingenuity. And art, in its various forms, has always been a manifestation of this. This connection is biomimicry. Biomimicry is more than just an innovative strategy we've developed in the last few years. In fact, this talk may be the first you've ever heard of it, but I believe biomimicry is the evolution of art, architecture, technology, medicine, innovation itself, and life as a whole. But what do I mean by this? Well, it's clear that biomimicry is the culmination of billions of years of natural selection, refining and perfecting designs that we now try to mimic to solve complex human challenges. But why are we trying to mimic nature today? The answer is simple. Nature is incredibly efficient. Over 3.8 billion years, natural selection has fine-tuned systems to be sustainable and reliable. Think about a bird's wing. Birds have been flying for millions of years, and their wings are perfectly designed for the task, down to each feather. When engineers wanted to design airplanes, they studied birds. And by mimicking the structure and shape of a bird's wing, they managed to make airplanes that could soar through the skies. I find it comforting that in nature, there's logic and reason behind every single shape, every single curvature, every single hair. There's a seamless connection between function and form, which leads to designs that are not only sustainable, but groundbreaking, making the most optimum use of the limited resources we have in nature. Let's jump to the earliest era we can think of. Think of the earliest humans, these guys. These are called the Homo habilis, or the handyman, who lived about 2.4 to 1.4 million years ago. Believe it or not, early human innovations often drew inspiration from nature, even if not explicitly recognized as biomimicry. Picture them chipping away at rocks, creating sharp edges and ridges that mimicked the teeth of predators or the curves of plant stems. And now look at these cave paintings behind me. These paintings, often depicting humans, abstract symbols, animals, they show that art is something deeply natural to humans since the dawn of time. And just as Homo habilis created stone tools to shape their world, so too did they create art to express themselves and to build connections with those around them. Let's jump a few eras. Ancient Egypt, ancient Egyptian architecture, columns, specifically looking at the columns in the Temple of Luxor, similar to other columns present within the era. These columns often mimicked the look of lotus plants or papyrus plants, as you can see in their curved ridges and distinct forms. But ask yourselves, why not a rose? Why not a lily? Why a lotus? Well, to put it simply, think about the number of petals a lotus often contains. 8, 16, 36. It's almost always an even number. This ensures that no matter what, there's always a perfect number to equally distribute the structures that these columns uphold. which is why the lotus was not just used in ancient Egypt as a base ground for columns. It was also used in Persia, in Rome. Jumping from Africa to Asia, I can talk about Madhubani paintings. Originating from Bihar in India, Madhubani paintings often depicted animals, big human events, or even just flowers. But the main focus of most of these paintings have always been peacocks. Why? Well, you could say it's because it's India's regional bird, but also because of their distinctive color palettes. Think about the rich copper hues or the luxurious blue tones. These colors, the dyes that were made for this color palette, colored generations of textiles that came from this era. But where are we today? One thing's for sure, evolution is not a thing of the past, and it's continuing even now. As we stand at the intersection of technological advancement and ecological awareness, the ancient art of biomimicry emerges as a new form for us to delve into. Moving on. Tokyo. A bustling metropolis with over 40 million residents. It boasts one of the most sophisticated metro systems in the world. Every station, every route, every timetable was crafted with painstaking attention to detail over the 26 years of its development. But here's the kicker. A slime mold, a simple cellular organism, accomplished the same feat in just over a day. Decades of human engineering, countless hours of planning and innovation, all mimicked by a brainless organism in a matter of 26 hours. 26 hours against 26 years. This is where we are today, where the power of biomimicry is more evident than ever before. Now let me tell you what biomimicry is to me. Some say it's a philosophy. Others say it's a new design interpretation, while others call it a scientific approach. But all in all, biomimicry is the exact same concept we've known for hundreds of years. Just as Homo habilis shaped their world with the stone tools of their own creation, so too do contemporary innovators today take inspiration from the efficient processes of beings today. As an aspiring architect, I can talk about many examples in architectural design that follow biomimicry, specifically looking at the one behind me. This is a building designed by Mick Pierce that was referencing a termite mound. Originally, termite mounds expel the CO2 they produce, maintaining a cool temperature constantly throughout their nest that remains the same no matter what the outside conditions are. By doing this, the passive cooling system makes it so that the East Gate Center uses 90% less energy than other buildings of its conventional size. I'm sure you recognize this. Expo 2020, that's right. So I'm sure you remember the tall, almost mushroom-looking towers that decorated the sustainability pavilion. These towers are covered head to toe with about 4,000 square meters of solar panels, adjusting their positions throughout the day to make the most optimum use of the sunlight around them. Next, if we talk about less direct matters, Zaha Hadid, a world-renowned architect that inspires me particularly. I mean, look at this design behind me. It's fantastic. She was known for her radical deconstructive designs that always mimicked nature in some way. Nature was her muse, and she would make buildings that would look like the cascading waterscapes. On more artistic terms, has anyone seen the stuff microbiologists are cooking up in their labs? Yeah. They're hosting art competitions using live bacteria, yes, alive specimens, to decorate their Petri dishes in a whole new way. Michael Hamsmere, in his TED Talk, mentioned the possibility of creating buildings or objects that were unimaginable, unrecognizable. How? By using the simple concept of mitosis. If you think of mitosis as simply folding a piece of paper with more folds creating more divisions the more you do it, what if you apply this onto a 3D cube infinitely? Well, what's interesting is you get different structures each time. Each one varying in its fractals one by one. With a little bit of polishing and fine-tuning, you get something like this. But let's bring this back to architecture. If you were to apply this on something like a column, for example, take 4 simple cylinders, input this principle, and you get something like that. Pretty cool, right? Maybe in a few decades from now, we could live in living cities. Imagine cities that function like organisms, constantly adapting and evolving to our varying needs. Algorithms could become ecosystems, changing with the world around us, from traffic flow to building temperatures. It takes ergonomic to a whole new level. As members of Generation Z, we find ourselves with the most powerful tool in the world, biomimicry. And as we pass the torch on to future generations, we can ensure that this amazing field is never forgotten and is taken with us in the future. Just as art evolves with each stroke of the brush, so too does our itinerary to build a more colorful future. And this, my friends, is how biomimicry represents the evolution of artistic innovation. And rest assured, we are just tapping the surface of this amazing field. Thank you.